All right, welcome to session 303, Building Solutions with Serverless on Kubernetes Engine. We actually wanted to call this Building Solutions with Cloud Run on GKE, but for obvious reasons, we didn't have that session title until just now as I'm saying it. So what we're going to be talking about is our new offering, Cloud Run on GKE, and how you can take advantage of it. I'm Donna Malayeri. I'm a product manager.
And I'm Mark Chmarny. I'm one of the technical program managers looking after serverless, specifically things on top of Kubernetes.
All right, so let's talk about Kubernetes. It's really fascinating. Kubernetes has basically emerged as the de facto standard for container orchestration. You know, it's really picked up steam, and people who've been using other solutions are finding Kubernetes is great for their needs, which is awesome. And there's a huge ecosystem. There's a ton of companies building on it. There's jobs that are growing. The stat that I saw was the jobs are growing 250% month over month. And I think the real test that a technology has taken off is when recruiters ask for 10 years of experience in it. And of course, Kubernetes has not been around. There are very few people who even have 5 years experience in it. But that's how entrenched it's become. People forget how new it is.
So the very popularity that Donna was just talking about of Kubernetes is also driving a large number of use cases, growing number of use cases that people try to use Kubernetes to address with. That means that today, Kubernetes is able to do the container scheduling that was able to do at day one, but it's also able to do load balancing and identity management and authorization and many other services that make the operator, the Kubernetes operator experience very, very friendly. Their work is made simpler. Kubernetes obfuscates a lot of the complexity of the underlying infrastructure from them, so they don't have to worry about the VMs or whatever else is underneath. And to a large degree, even better when you run on top of a managed Kubernetes service like GKE, which makes this whole experience so much better. So that ubiquity, the fact that Kubernetes is available pretty much in every single cloud service provider today, it's hard to find one that does not offer a Kubernetes service, means that developers are naturally interested in that service. But their experience is not as smooth. Developers, I believe, on the end of the day, they really just want to write code. Just give me something to write code and make sure that it runs well. Developing directly on top of Kubernetes. So if you're a developer and you're writing application, Java, Go, Python, whatever it may be, it's possible, and people do it, and there's a lot of tools around it that make it possible, but you have to stitch those tools just right. You have to make sure that they work perfectly. And there's a lot of toil that's involved also in this process. So you have to, besides just building the images, which at this point, frankly, everybody does, but there's also, exposing that service to the outside world or managing traffic. And also, to a large degree, Kubernetes is still optimized for batch workloads, which amongst many other things, means that it scales on CPU. For modern applications that you're writing today, CPU scalability is probably not the right way to do that. You're looking for low latency of response. You're looking for ability to scale up and down. And all of that is not directly available to you as a developer. So modern stateless application development on top of Kubernetes definitely could get better. And we'd like to have Donna tell us about that.
All right, so our solution to this is Cloud Run. This is the new product that we've launched this week. And we're bringing serverless to containers. So what does that mean? Now, serverless is an interesting term because of course, it's a misnomer. There are obviously servers involved. And it's also an interesting term when you talk about a cluster that you manage yourself. So what we talk about is a serverless developer experience. If you use the fully hosted Cloud Run, which is the default one, if you go into the Cloud Run console and create a service, it's fully serverless. There's no cluster to manage. You only pay for what you use. Essentially, Google Cloud, is your operator. We're managing all of that underlying infrastructure for you. Now, the reality is that when you have a cloud vendor as your operator, there's a lot of assumptions that we make that may not suit your needs, and that's where Kubernetes comes in and Cloud Run on GKE. And what this means is, if you use Cloud Run on GKE, your operators have this great Kubernetes experience. You can set up role-based access control, networking policies, you can decide what cluster you want, all that kind of stuff. But developers are abstracted from this, and they have a serverless developer experience that can scale up and down. So Cloud Run on GKE, compared to the fully hosted Cloud Run, gives you a lot more flexibility. Of course, there's more to manage, but if that's what you're already intending to do, it can be a great choice. If you already have GKE, Cloud Run on GKE is a great option. So you have more machine options, you can run on GPUs, you can access more things that are currently integrated with Cloud Run on GKE.
Thanks. So Donna has explained kind of the differences between the two flavors of Cloud Run. Cloud Run gives you the consistent developer experience regardless where you run it, whether it's on a managed service or on the, Cloud Run on GKE. But coming back to the original picture that we talked about, when developers use Cloud Run, some of the things that they had to do before are still happening. They're just happening behind the scene and happen automatically, or they are made much easier. So you continue getting the very same power of Kubernetes underneath, but you're able to benefit from a lot of automation that Cloud Run on GKE delivers to you. And what that means is that you don't have to focus as much on the manual step, the shaving the yak, so to speak, over and over, building these images. There's way to integrate other, exposing the service to the internet. And because Cloud Run is supporting Knative APIs, and more about that later, you will be able to preserve that same developer experience, whether you run on Cloud Run on GKE, Cloud Run hosted, or whether you run on top of another Knative compatible offering, whether it's on-premise that you run yourself, or whether it's consumed from another provider. So let's go a little deeper into some of the benefits the developer gets from running Cloud Run on GKE and what that means to them. So first of all, I was talking about automation. There's one of the key features that we talk about with regards to Cloud Run, whether it's on GKE or on Kubernetes, is auto-scaling, which means that you as a developer can write your application and be able to respond to unpredictable usage patterns, whether it's a disaster that suddenly creates lots more demand on your service, or whether Justin Bieber tweeted about some jeans and your marketing application has to respond to some service much more, or be able to scale much larger audience of visitors. What it also means that Cloud Run manages your code and configuration as unit. The benefit of that is that you have at all points the ability to go back to the last known state. So it's not just the code that was compiled at a certain version plus different configuration, and suddenly you have to change the differences. It's a unit that snapshot whenever you apply change to the service that triggers them together. The other thing is that Cloud Run underneath, on Cloud Run on GKE underneath, is using Istio, a very powerful mesh service that in order to make that accessible to you, we expose a very easy to reason about object model that allows you to deal with things like routes management or observability around metrics that you want to capture. So in a situation of a very common situation, for example, when you come to the conference like this, you get excited about particular technology, you deploy your application, it runs now, you have users, great, and now you say, I want to run a change. I mean, if it was me, I would probably have a bug in there, so I have to fix it, but you write a perfect code, so no problem there. You want to make a change, but you have active users. So how do you do this? So the ability to manage Istio underneath and manage those routes reliably allows you to support things like blue-green deployment, where you have a new version of application or experiments which you can actually start sending incrementally larger number of percentage of traffic to this new version. And on top of this, also Cloud Run on GKE is also pluggable. What that means is that it connects very well with the series of native services offered by GCP, as Cloud Run or Stackdriver, whatever it may be, and Donna has listed a few other ones there. But it also is extendable by our partners, and there's a number of them out there. The ones I want to highlight here is GitLab and Datadog. If you've been in developer space, you probably are aware of those companies. No.
All right, so enough of slides. Are you all ready for demos? You don't seem very excited. Are you ready for demos? There we go. All right, so for our first set of demos, we're going to show you how you can have easy request-based activation and scale on demand. For this, I'm going to invite Mike Momsen from Airbus Aerial, who's going to talk about how Airbus is using Cloud Run on GKE.
Hi guys, I'm Mike. That's a photo of me with shorter hair. So I'm a dev. Like I work as a back-end dev. I'm going to show the way that we can use Cloud Run to make our system simpler. Here we go. So who are we? Our goal is to be your one-stop shop for all your spatial data needs. So we have satellite data from our set of satellites. We have a very massive set of satellites. We can get you satellite data each day down to 50 centimeter. It's fantastic data. We also have manned, which we're calling airborne here. And when you go and you see a map online and they claim it's satellite, it's almost always manned. And then we also have drone. Drone's great for 3D models or very close-up inspection. So we have all this together, all on a web browser-based system. It's very simple if you're not a GIS expert to use. We can also bring in data from our clients or data that's different than this. So we have it all together. And one thing we've been, one of the use cases that's been great for us for helping our clients has been all these natural disasters. So I actually was in this room yesterday. I saw a talk by a guy from Mayday AI, and he said that 70% of the US is at risk for a natural disaster. So there are the fires out here, there's the floods in the Midwest, and there's the hurricanes out east. When we have a storm like that, no one knows what's happening on the ground. It's a total wreck. You can't get through with cars. So to have some sort of data available allows the first responders to know what's going on. So in this case, there was just a little tropical depression on the 7th and 8th, and then all of a sudden it became a huge storm on the 9th. It crashed into Mexico Beach on the 10th, and on the 11th we had data inside our portal for our clients to use. So it's very impressive how we can get data from a satellite into our system and in front of our clients in a very quick fashion. This is actually very important for our clients. If we have a client that's an insurance company, if they see that picture right there, they don't have to send someone out. They can just cut checks. And this is very important to the people that were in these homes. They can start their lives a lot quicker. It also saves a lot of money for the insurance company because they don't need to send out people, which can cost $6,000 to $8,000 just to send out a single person. So helps people in real life, and it does some good for people. So I'm going to show how we do this. So this is our spatial data processing pipeline. So starting on the left, we have raw data coming in, and all the way to the right, we have our web browser. Each of those arrows is a program written by someone like me, wrapped into a Docker container with lots of good code and OS, and then on top of that, a ton of YAML so we can send it up to the Google Cloud. I actually joke that I'm a YAML programmer at this point because I'm sure most of my lines of code are actually YAML, but that's the way it's, it has worked for us. It's a pretty good system, but as you can see, it's pretty complicated. I'll just walk you through what would happen with a satellite. So that would be at the bottom here. If we get satellite data in, these are crazy data sets. They're 80,000 pixels by 40,000 pixels. And we don't have to process one of them. We have to process tons of them at a time. So it'll be lots of them coming in. And then we load those into Google Cloud Storage. And we have to process those into images that are things that our map server can serve up so our clients can see it. So there's lots of steps to get our data from our source all the way to the browser. It's not terrible, but this is the system we were using. At the top, that's vector data, so that would be stuff like parcels and whatnot. So I'm going to show the way that we can improve this with Cloud Run. So this is replacing all of the image processing. We don't need all those intermediary files because we can scale down and up. Very simply, we can skip all the pre-processing, serve off of an individual file. So we have one TIFF, and we can use that TIFF for all of our machine learning. We can use that for all of our spectral analysis, and we can use that for our map server. So this makes our data a lot simpler. It's like this is the way that we think of our data. It's a satellite capture. We have one file we store on Google Cloud Storage, and from there we can do all the things we need to do with it. This is very easy for us to implement because we already have everything as Docker, so we can just basically send that Docker image up at Cloud Run, and it works. If we do want to try out a new deployment, we can do a blue-green, so that's fantastic. So, I mean, this is a lot simpler than that previous slide, and I like it a lot.
Show us.
I'm going to show you guys. All right, so this is a demo of that map tiler that I was describing. So this is actually running on Cloud Run. And you saw those tiles as they were loading. Each one of those tiles is a request that goes to the Cloud Run server. That Cloud Run server sends a request to GCS. And then it gets the data back, and then it recompiles it. And it makes a tile that we can see.
Donna has a question.
So this might be good for you because you're a geospatial engineer, but I can't see anything. Can you please enlarge and enhance?
So this isn't CSI, so we can't do the enhancing. But
real time?
No, we can't. But actually, because we didn't have to pre-process the image and we could serve straight off that TIFF has a lot more colors in it, and we have to reduce the amount of colors that go to the browser. So because we didn't have to pre-process it, we can actually change the way that we show the colors. So this is that same image that I was showing over here, but we did a stretch to it. So previously, if we would have messed up the stretch, and this does happen, we would have had a dark image or a light image. But now we can expose to our front end or to our clients ability to change the way that they view the image. So I can get in here, and I can actually make this image look way worse. So rather than doing a stretch that goes between 2% and 98%, I'll go from 2% to 70%, and it's washed out and looks terrible. But it shows that we can do on-the-fly processing, and it's going to change the way that we can use our whole spatial data processing pipeline. And I'm very excited to take this and apply it to all the other arrows that you saw in that previous slide. Thanks, guys.
Awesome. Thanks, Mike. What I really like about this demo is that you didn't have to, you can move away from batch processing, but you also don't have to design for peak capacity because you can't really plan for a natural disaster. And if you're not using something like serverless, you would have to provision a lot of extra machines. But here, when customers want this data, this image data on demand, you can do this scaling. And that's really the power of having a serverless developer experience. So if we go back to the slides. All right, so Mark, in this case, Mike had a container image. Can you show us what happens if you only have source?
Good. I guess we're going to do a quick overview here, maybe first. Can we go back to slides for a second? So I can do the demo in a second here, but I want to just kind of walk you through. So a lot of times, we talked about developers just wanting to write code. So in a kind of a GitOps-like setup or use case, what that means is the developers are committing their code on an ongoing basis into code repository, and there is a series of unit tests on their machines and their integration tests that are running on against the code repository. So whenever a new commit comes in, it's executing. But sooner or later, the release manager will come in and say, OK, I'm ready to make a new cat and deploy new deployment. So they will come in, they will create a trigger. What we're going to show here is the integration of Cloudbuilt, which is another hosted offering from Google that's managing the build process. We're going to create a trigger in there that's going to go through the series of steps and deploy a new image to Cloud Run. So 100% transparently, no user involved. All right, let's switch back. So what I have here is a clearly for demo design application, unless you're in a prime number calculating business, and who wouldn't want to be in that. That's kind of all it does. You give it a number, and it calculates. I don't know, let's do something different. Great, so we got number. It's really not, the application is really not important here. Please don't focus on that. What's interesting here, a couple things. First of all, we use this also as a REST service, so you can You can use it to test the scalability use cases because you can pass a larger number, which will consume more CPU, but also not something we're going to do today. The part I want to focus on is over here. What we have is, for demo purposes, we're injecting the release tag that was assigned by the release manager in a repository so that we can, when this entire application travels through the pipeline I showed you before, we can actually see it. So let's take a look at this application. This application, again, the application purpose is really not relevant. What we're going to focus on is the release manager process. There's 46 releases. You can see we've been busy testing this. So I, as a release manager, are going to just create a new release. And you know what? Let's call this something like a
next demo.
Next demo. That's a great idea. And next demo. And because this is demo, hopefully you do better release notes than I do in your production system. And when we fire this, what actually is happening here is that Cloudbuilt automatically notices this. So let's go kind of deeper into this process. What we have here is information about the status of that particular build, including the repository that it came from. But it also has a trigger that we can kind of interrogate. So what happens here is the trigger is set up. It indicates where the repository was. So in this case, was the GitHub repo that we went to. Has some name that you want to be able to use. There's two different ways you can trigger this. You can trigger it on a branch created or for QA, QC kind of purposes. But in this case, we went with a tag. And the tag has a regex, in this case, release v, anything after that. Whenever Cloudbuilt sees one of those tags, it will build the entire process. And there's a configuration file. But let's go over here quickly. History. Let's take a look at this. So this build configuration has a number of steps, and those are defined by you. So you can build simple only test. You can run a build process and push repository. But what we're doing in here is we're copying the entire source code. We're running a test. We're building an image, publishing the image to the repository, image repository. We're creating a manifest in order so we can inject that environment variable and other configurations that you need and deploy it. And obviously, there is a log file, and you can access this. So hopefully, if everything worked correctly, we can come in here, refresh it, and you see my next demo label. This happens transactionally, so the requests that were being served by the previous version of release are being completed before a new one is being sent to the user in response to our HTTP request.
All right, Mark, I think you should make this better. So I noticed that when you were in the Cloudbuilt UI, you were refreshing to see what the status is. Can you have us trigger?
Yes. So as part of our demo, again, we're going to do kind of an add-on process. We're going to go in and use one of the features of Cloudbuilt, which publishes build status changes into a PubSub topic. PubSub is a globally distributed, simple-to-use Elastic message queue service offered by GCP. So whenever you have a Cloudbuilt in your project configured, it will automatically create that topic for you. So you don't have to do anything there. What we're going to do is we're going to create a very simple subscription that will watch for events on this topic and send them to an image, to a notification service that will relay them to Slack. If everything works OK, we will see this whole thing work automatically. So let's take a look quickly at we can close this, at a simple notification service that we're going to deploy in here. So this notification service, among many other things, is a Go application. But the two things to focus on here is it has a handler, so we'll receive the push from a PubSub topic, and really does many different things. But on the end of the day, it just really extracts the notification that was there, so strongly type object. In the Node.js, you might get away by simply taking this and sending or any other dynamic language. And then it sends it to a sender that decorates it with a beautiful Slack message with icons and everything, and shoots it over to on the very end to Slack. Again, this is not as important. So let's go. Where are we? let's go to command line. And what we're going to do here, this is very gnarly command line, but so let me break it down. We're going to deploy this service. First of all, we're going to use gcloud, which is a CLI that you're already very familiar with if you're using anything on GCP. We're going to use the run service, and we're going to deploy an application. I'm calling very fancy pops up notifications or something like that. The two things that we're going to provide is an image path. Now, most of the demos you have seen for ease of demonstration so far, we're using something like GCR, name of the project, and name of the image, which is great. It will work, except it's very unpredictable because what is the latest image today might not be the latest image tomorrow when your application scales down. So I'm going to use a SHA that is specific to the image. So it's very unique. Cloudbuilt has an ability to generate consistent, predictable images, so it can guarantee that that image is going to be the same, even if you reproduce that image over and over. So thankfully, I'm not going to have to type it because it's a very long SHA. The other thing I'm going to provide in here, again, in a lot of demos, we just simply run some command and it deploys it. But in a real world, you have some configuration. So I'm populating some few information in here. So let's run this.
So let me make sure I understand this. You wrote your own custom code that listens on a pub sub topic, and it posts to Slack, and this is what you're deploying right now.
Yes. So first of all, if you notice, hopefully you notice, because a lot of work went into this, deployment was fast. Like, I just run it, and the entire image from GCR and deploy it. In fact, if you are hit it some with my application now with some traffic, that same performance will be true for every single new instance of the application. That is pretty awesome. But the one thing that we got here, two things we got here that we really care about, is a specific revision name of the instance that we push. We remember to the example I was talking about before, where you can come back and say, you know what, the new deployment I just did, not good. Some tests did not work. Let's go back to last previous known state. You can list those states and you say, go and make this one active. But the other thing, more importantly, what we got here is a URL. My instance is automatically configured with a custom domain and with SSL certificates, so everything is working. And what we're going to do now, hopefully you can see this, we're going to create the pops up back to gcloud, pops up, subscription, create, and everything has to have a nice long name, so this is mine. And two things that we need to care about here. One is we define the topic. Remember I told you that Cloudbuilt automatically creates a topic for you, so this is constant name. You can always use it. There's one of those in your project. And the other thing we're going to do is we're going to define a push endpoint. Pops up can work either as a pull, when you go in and attach a client and get events, or it can work as a push. So in this case, we're using a push. Whenever there is a new message on a topic, a subscription will be created that will push that to our service. The other thing I'm doing here worth noting is, because I don't want you to start sending events to my notification service in Slack, I'm sharing a token between both of those that allow me to make sure that only known publishers can go for it. So let's run this.
So basically, this pub sub topic is what's creating the connection between Cloudbuilt and our Cloud Run service that we just deployed.
Yep. So now we have our image published, service published, we have our subscription created. So let's go back to browser. Max Prime, and we're going to create a new release. You've seen this already before, so nothing new in here. I can't type, sorry. I don't think it really matters for the demo, but let's go with 4. How's that? Better? New one. The name is not relevant for this over here. The release number is the only thing that matters. So we're gonna publish this, and don't worry, I'm not gonna make you go all the way back to Cloudbuilt status to watch this exciting progress going. We're gonna go quickly to Slack. I'm using the Knative public channel, so if you're working on Knative or interested in a project, you can always join this. But the thing you will notice here is that we've automatically have published this saying, hey, I'm working. So what happened is that Cloudbuilt said, I'm starting to work on this. I went in, I I publish new status called working, and that status travel through PubSub all the way to our simple notification service that really just decorates nice messages and sends them to Slack, and Slack displays this. The other thing that we have is we have a link directly to that build process. So hopefully by then we should be getting pretty close to being done. Where are we right now? We are on step 1 still. So this will run through the exact same process. And then eventually we'll get to the point where we have here, which will publish a, hey, I succeeded. You can customize this the way you want it. There's nothing fancy in here. It's just what we're showing is that you can wire that to very simple webhooks or services that are connected together. Do we want to wait for this to finish? How close are we? There, we're done. Let's see if we have our final status. Success! I usually get a clap for this, but OK.
So the interesting thing is that this application that listens for these PubSub topics and publishes is Glue. And this is Glue that is typically written in a functions as a service on a hosted, say Google Cloud Functions. But here with Cloud Run, you can run that Glue code really easily in your own GKE cluster.
Yeah. So can we change the slides? Oops. Yeah. So this is just a very quick summary of what we've done. You've seen the first one already there. PubSub topic is being configured with a new subscription. You can have n number of subscriptions. So we have clients listening and pushing and all that. We've deployed a service, and that service went to Slack. There's a number of CI/CD companies. In fact, if you come to any of the other Cloud Run services, you will see, for example, some of our partners integrating with this. So you might not, for example, say, Cloudbuilt is not what I like. I like, I don't know, Jenkins, or I like GitLab. Those partners have active integrations with Cloud Run and GKE. All right. The other thing that often happens is, like in all the demos, because demos need to be simple to show during the conferences, we often deal with this use case where there is a one service, very simple UI, something, because you have to illustrate. But in the real world, you have a situation where you have to combine things together. So hopefully you're kind of following like a 12-factor application development model, or you have a series of microservices that you stitch together. Cloud Run, in addition to what I'm going to show you, also like I said, introduces a service mesh, so you can bind those services in much more usable manner. The example I like to say is that it's very simple to manage 3 microservices. When you get to 10, 20, 100, you can't rely just on your own. Hey, I know, remember the URL over there or something like that, because they just connect together, right? So what we're going to do here is we're going to build our little more real-world solution. I'm going to deploy a service that it's doing nothing else, just exposing a REST API for user to request the service to identify a logo. So we're going to send a bunch of images, and it will tell us what logo is in the particular image. It's using behind-the-scene Vision API, which is part of our ML stack. You can use anything else. What we're going to do then is we're going to come in and say, OK, great. Vision API uses credits. I don't want the entire world to use my credits. So I'm going to front this application with a simple OAuth application, which is going to use Google OAuth service. And I'll expose a nice visual UI to it. So no longer curl commands, but we're going to use a simple UI. I'll build this all myself, so don't expect any beautiful graphics there. But if you are really kind of paying attention, you quickly realize that there is nothing stopping somebody continue doing this. Now we have a number of microservices, and if you've used some of our other services, we have that situation where everything is exposed to the internet. So in this case, on Cloud Run, what we provide a way is to deal with that. So let's switch back to a command line and, sorry, to demo, to command line. Can you switch to a specific window on my machine? All right, so what am I going to do here? I have, how big is this? Is it big enough? I don't think I can go any bigger than this.
Can people see it?
So what we're running here is we've executed a simple curl command. Let's see what the image looks like.
So here this is the first slide that you just showed,
Yeah,
right?
we're going, sorry, I've walked you through the entire process. We're going to go back and kind of navigate this. You and I know this is Kubernetes, but for a machine, I'm not sure what they know what it is. So what we just invoked here is the service in a step 1, where we directly got the result from a Vision API that was managed by that REST service that we exposed. By the way, the Vision API exposes all other attributes that I'm kind of just hiding and disregarding in here. But I'm just bringing the one for demonstration purposes. So let's do this. Let's go in now and take a look at the demo application. So kdemo. Simple application. Like I told you, no beautiful graphics there. But what it allows us to do is come in here and authenticate. I'm going to use my personal one for this. Is this visible? Yeah. So what that allows us to do is, ask the very same thing in a much more user-friendly way. So you can click the images, populate. You can paste your own. Again, the application doesn't really matter. So we have our simple UI that forces users to authenticate, so we know who is running. Great, except now, still no bueno, right? I can continue running this directly against the backend service. So let's come to a cloud UI. Oh, that's the wrong window.
So basically, you added a UI, and you allowed people to sign in, but you didn't protect the service so people can still get to it directly.
Yeah, so I'm looking at the Cloud Run UI here. You can do the same thing in a command line, but I've noticed that we don't show much of the Cloud Run UI in demo, so this is my mission for today. The other thing you will notice here that I have mix and match of services. You will see some things that are running Cloud Run on GKE in a particular cluster called Next, because I can't be creative anymore. Or they're running on the managed service, the same interface, the same developer experience, the same operational experience that you've done before. So let's go into our K-logo service that's on Next. You see the image that we publish and everything else. But one of the things we can do in here, we can actually come in and very easily, you can do this from a command line, by the way, too. We can change this to internal. And two things will happen. Let's do no longer jQuery because it'll be easy. Let's do more verbose. Curl give us a lot of things. But the one thing I really care about is here. Our HTTP status, by the way, did you notice HTTP 2? Huh? It upgraded automatically. The other thing that we see here is the status for my service is now 4.4. It's not that we have protected this. We have made it not visible. So it's only accessible in a cluster local. Now let's see if our UI continues to run. If I can only find the demo here. There we go. Let's make a new one. Droid. There it is. That was it. So let's switch to slides maybe, quickly. I know it was a lot moving parts, so I'm going to bring a slide here that kind of helps us understand. So what we've done, we've created services. I actually added behind the scene another one because I don't want you to continue abusing my service by running the URL now multiple times. So I'm adding a user service that's using a Firestore for persistence of data, a very scalable data service, very easy to use, and does metering. So I think I have like 100 queries per user per day. So if you are being very diligent, it will probably block you there eventually. But the other thing we've done is very quickly made both of those backing services that don't need to be exposed externally directly. We made them cluster local. Fancy term for saying they don't have an external URL, but they do have a URL that can be discovered by my front UI and connect to them. That's it.
Yeah, so basically what you can see here is this is a more realistic application where you actually have multiple microservices, you're protecting your services, and you're making sure that things are production ready. Because there's a big gap between what works in demos and what works in production, but we have things available for both of those scenarios for you. So what we showed you was the developer experience for Cloud Run and GKE, and you saw when Mark showed the Services tab in Cloud Run, it's actually the same developer experience. There's just different configuration options that are available in each environment. And you can mix and match. You could decide, well, I have a cluster already. I'm going to use this spare capacity to do part of my workload. I'm going to put some of it on hosted Cloud Run. You could change your mind later, move it back. It's extremely easy. And because it's all powered by Knative, you're not using a particular API that may not be available in some other environment that you're running. So your workload is portable. There's another thing that's portable, though, that I think it's really important to know. It is your skills as a developer or as a tech person. You know, we have a limited amount of time to learn some new framework and some new stack. And it's hard to know what thing to learn that's actually going to be durable. It's going to be useful in multiple environments. And this is one of the things that Knative gives you. Because it's a standard, consistent, developer-friendly API that is available on multiple vendors, not just Google Cloud, you can know that the things that you've learned you can use elsewhere. So multiple teams working in the same company can have a consistent developer experience. So thank you very much. If you want to learn more, you can go to cloud.google.com/run. The Knative website is also available now at knative.dev, and you can also ask us questions on Twitter.